This is a solution to problem number 96 from homework 3.2. So we're given a graph of a function and we're supposed to describe a polynomial function that could represent the graph. And in particular, we're asked to indicate the degree of the function and the sign of its leading coefficient. So we're going to combine the leading coefficient test as well as what we know about turning points to determine the degree, a possible degree, and the sign of the leading coefficient. So in graph A, we can look at the end behavior. So for the end behavior here, this graph falls left and rises right. Since the ends go in opposite directions, I know that this is an odd degree. So I know that to begin with. And then in terms of the sign of the leading coefficient, if it falls left and rises right, this is like x cubed at the ends, right? So I'm going to draw the ends of the x cubed graph. So I know that this has to have a positive leading coefficient. And then in terms of what the degree can be, let's look at the turning points. So this graph has 2 turning points, and the number of turning points, the maximum number is the degree minus 1. So the lowest degree that this function could have would be 3. If it were a first degree, it would have 0 turning points, so that's not possible. So I would say this is a third degree polynomial function with a positive leading coefficient. The next graph. Here, let's look at the end behavior. So as far as end behavior goes, this graph, we would say it rises left and right. So the ends look like that. Since both ends go up, or both ends are rising, this is like the graph of y equals x squared, which means that it has a positive leading coefficient. And in terms of the degree, we have 1 turning point, so we need at least a second degree. So I would say this is, we know for sure it's even, and then based on turning points, we would say it's degree 2. For graph C, let's take a look at the ends. So in terms of end behavior, this graph is going to rise left and right. So let's describe that. So it rises left and right. Since the ends stay together, I know this is going to be an even degree. And since both ends rise, this is like x squared. So I know that it's not like negative x squared. That would mean both ends go down. So the leading coefficient is positive. And then in terms of specifically what the degree can be, let's look at the turning points. So this graph has 3 turning points, which means the minimum degree has to be 1 more than the number of turning points. So the minimum degree for this polynomial function would be 4. Last graph, let's look at the ends. So in terms of end behavior, this graph falls left and rises right. Since the ends go in opposite direction, we know this is an odd degree polynomial function, and we have to decide whether it looks like x cubed or a negative x cubed. So the graph of x cubed, the ends actually fall left and rise right. So this graph is like y equals x cubed, which means it has a positive leading coefficient. And in terms of what the minimum degree could be, I'm going to count the turning points. So this graph has 4 turning points, and if it has 4 turning points, the minimum degree has to be 1 more than that. So this could be a 5th degree.